Laura Evans, and she has assembled a team of 4-H staff from around the state. So Laura's with 4-H in the Kansas City area. I don't know exactly what that means, but I know it's Kansas City area. She can tell you a little bit more about who she is and what she does, but they're going to talk about experiential learning and kind of the 4-H development model today. So I think we're in for a treat. So if you got questions, put them in the chat box. And Laura, I'm going to turn it over to you. Thanks for being with us.
Thanks, Brad. I'm going to go ahead and share my screen. Before I do that, here we go. Okay, are you guys able to see my PowerPoint? All right, awesome. So my name is Laura Evans, like Brad said, and I'm just grateful to be here with you guys today, just to share a little bit about what 4-H is, and then also the kind of different types of models we use and how do we connect computer science to that. So again, I'm with University of Missouri Extension. I've been with Extension for 5 years, serving Platte County, which is on the northern side of Kansas City, bordering up with Kansas. I am actually, believe it or not, a kind of country girl at heart. I was born and raised just right out of St. Joseph, Missouri, out in the rural. And so moving down into the urban areas has been like a little treat for me, because I'm able to share my urban ways, or my country ways, with the urban, but yet the urban's teaching me a lot of different things as well. And so today I just wanted to make sure to introduce that we do have some special guests with us today. I've got my colleagues, Kim Hall, Amanda Mink, Lane Anderson, Crystal Huber, Caitlin Edwards, and then also Beth Rossa Edwards. And they're going to be leading some breakout sessions for us today. And you'll get to meet them here shortly. But today I just want to be able to be with you guys to share a little bit about, like I mentioned earlier, share a little bit about computer science, share a little bit about what 4-H does with the experiential learning model, and how does that all connect. And we're going to get out into breakout sessions, so make sure to start thinking about being active and start asking those questions. I like for today to kind of be interactive as much as possible. Feel free to stop me as we kind of go through, but there will always be time for questions at the end as well. So to get us started, Brad's gonna start a poll. I don't know how this actually works, if I need to stop sharing so he can share, or how that works. There we go. So if you guys could tell me, where do you guys rank in computer science? Are you guys experts? Are you like, nope, not doing it, I'm not going there? Kind of tell us how you are most comfortable with computer science. And as of right now, I see the poll kind of jumping here and hitting this about everywhere. So you guys most people are kind of sitting at the 3, 2, 3. We have some 1s, 1 being the least, 5 being the most.
If you're on a Chromebook, the polls don't work on the Chromebook. You can which is okay, because you can just type it into the chat box. I'm seeing lots of 2s and 3s, Laura, in the chat box as well.
Awesome. And I was right with you guys. So when I started my journey in the youth development field, I started actually in the after-school place. I started in college with the after-school, and then I moved into being a para at a very rural Northwest Missouri, rural school district. And they asked me to be a para and a computer keyboarding teacher. And I'm like, that's not my background. And so I got into it, and I'm like, I'm type of person that I just jump in with both feet. A lot of my colleagues will join to validate my my philosophies and my philosophies and my background is where I don't say no a whole lot of things. I take and strive of learning and doing the do, reflect, apply. And so we're going to talk a little bit more about that today, but I just want you guys to know that it's okay not to be at that 4 and 5. We are at a generation where a lot of us didn't have the and our audiences that we reach. And so know that it's okay, but I want to make sure that you guys get the tools today to feel comfortable taking activities and going out and teaching those kids about computer science. And so let's talk about experiential learning model, and then we'll jump into some computer activities. So, all right. So the experiential learning model, there's 5 different steps. There's the first step is experience, doing it, performing it, and looking at and doing and performing the activity. Okay, and then it moves into the second one. It is all about sharing, looking at the results, looking at the reaction, observation, and then thirdly, it talks about going in and discussing. What was the experience? We're analyzing, and then we're reflections. And then the fourth one is generalizing. It is looking at connecting the experience to the real world. And then applying it, what did they learn? What was your reactions, and how do we are going to apply what we learned to moving forward? And we're going to talk a little bit about why it's so important that we utilize this model when we're teaching youth. I don't know if you guys have ever had thought about it, is where, or even seen this, but research has shown that when we're able to see it, hear it, discuss it, and practice it, we're able to retain and remember that information 90% more than just seeing it, just reading it or hearing it. And that really, I don't know if you guys ever have worked with youth with disabilities, anywhere from dyslexia or learning disabilities, and you'll notice where they have to have that tactical, or they don't, I'm not saying they have to have it, but they are able to have that recall better. I have a daughter that is 12 years old. She is actually dyslexic. I also have some learning disabilities myself. And when I'm able to participate, able to really understand, for me to really understand it, and as well as my daughter as well with being dyslexic, if I'm able to see it, hear it, discuss it, and practice it, anybody would be able to have that recall and strengthen those needs. And so from here on out, we're going to talk about we're going to break down those 5 steps. I do have a video to share with you guys. It's just a very short video, and I'm going to share that now. Can you guys hear it?
Hi, I'm Anna. Today we're going to do relay programming.
Oh, sorry. I want to try to make sure it would go up, to turn up the volume, but we're going to just go with it. And I'll share the link with it later if you want to watch it later. But it's only about a minute, so.
Hi, I'm Anna. Today we're going to do relay programming. It's all about programming under pressure and debugging the mistakes that sometimes happen when you work really quickly or in teams. We'll use graph paper programming to simulate coding and use relay races to simulate having a deadline. Let's go! Relay programming teams will be racing to finish a graph paper program. You have to check your teammates' work or debug it. Fix it if there's a mistake. Add your arrow, and then run back and tag your teammates. Programmers use debugging a lot to find and fix problems in their algorithms or code. It has to be this one. There are lots of ways to debug problems. One of the easiest is to move step by step until you find where something goes wrong. Then fix it. Here I'm trying to do a back handspring, but I keep falling off. I walked through each part step by step and realized where my mistake was. My coach showed me I wasn't putting my hands on the beam correctly. So I tried to put my handspring on the beam with my new hand position, and I stuck it. I was really glad I debugged my back handspring. Figured it out? Yeah. Debugging is finding and fixing problems.
So just like how Anna had had tried do, reflect, apply. As you guys noticed that how Anna worked with a caring adult to figure out what was going on. And so as caring adults, we sometimes get stumbled of how to help our youth go through those processes. And we're going to talk about that a little bit today, about questions as professionals, what we can use to help our youth make those assumptions or go through the experiential learning model. And so one way to do that is to share. And so after a youth has gone through it, I want you guys to go in the chat box, what some questions can you do to help, or what questions can you ask youth to help them reflect of what they've learned. So if you wouldn't mind just taking a moment and just to type those questions in the chat box, and I'll try to monitor them as I go through as well. What did you do well? Absolutely. How do you know? How did you get from A to B? Exactly. And so being able to have those open-ended questions are the best. What worked well, what didn't? Absolutely. Good, guys. You guys are awesome at this. Tell me what just happened. Absolutely. These are some great examples that I see that are coming in, and I appreciate you guys taking some time to submit those. Some questions that came to my mind, let me get back up here, just like how you guys came up, was what did you do, what did you see, what equipment was needed to complete the task, and what part of the experiments was easy or most difficult, right? So all of these questions are great questions as we progress forward. And I'm going to kind of share why, here in a minute, I'm going to kind of share why we want to ask the simple questions at the beginning, and then we work into the harder questions at the end as we work around the model, okay? So on the third step is process. And so when discussing and analyzing and reflection, so our questions, as I mentioned, gets a little bit harder, not to be harder like to stump them, but to harder for them to challenge them and to start thinking outside the box. And so some things that could be is what challenges did you have? What would you do differently next time? What effect did the challenge have on your project? So just like how Anna was going through that box, that back handspring on the bars, she had to process and think about what she needed to change to get the end result, right? And so on the fourth area is generalizing, just thinking about what, and that connection of that real life experience. And so like how Anna was doing it on the coding complete pieces of relaying and debugging was a process of that. She was connecting it to her gymnastics routine, right? And so some questions that we can think about of working with youth are, what do you learn from the experience? Also, how does this relate from other things? What have you been learning? So looking through some response now connected to the chat box. If you guys want to start thinking about what are some questions, or what activity can you think of? How can we relate just like coding to like debugging to gymnastics? Can you think of another way to connect a project area to real life situations? Absolutely. STEM. Yeah. As those come in, I'm going to start thinking about, share another question. And another question would be, what other time that you experimented with to solve a problem? Personal relationships, that is right, Megan, right? We always use our previous knowledge about something to relate it to what we hope to be changed, right? Cooking, home economics, absolutely. Has anybody ever made a recipe that didn't quite go well? And so we are always doing something, or reflecting it, we're kind of debugging it, and then we're trying again, right? Absolutely. So our last and final concept of this learning model is apply. And so applying it is taking the new problem into it. So when we're faced with new problems, like doing a cartwheel, describe some things that you could figure out the answer. So thinking about how can you debug something or change things to make it happen, just like how we talked about cooking, right? How can you relate what you have learned in this experience to other parts of your life? Is it taking the relationships, maybe it was just an argument, like Megan was saying earlier about having a relationship is an argument and how to adjust it, or knowing that a certain type of communication is not best when you're working with others. So there's a lot of different things that applying, and so we're going to talk about that today, a little bit about on the computer science activities. So this next, for the next 20 minutes, we're going to look into 6 different computer science activities. We're going to start a breakout session soon. In those breakout sessions, they're going to be, each host is going to be in there. They're going to identify an activity, but as a group, I would love for you guys to be able to come back to the main group, this main group, and report about what is the activity, how would you use it in the future, just 4 or 5 sentences about it to share with others so they get a synopsis of how what that activity is. Make sure to turn on your computers, turn on your cameras, unmute yourself, and just get engaged. That's great. I'm so glad that you guys are back with us. I hope you had some great time and great discussion in your guys' breakout rooms. I'm looking forward to our next conversation on movement of different activities that you guys have learned about today. In 4-H, we are known for the wide variety of project areas that we have to offer, lots of different curriculums and different things. And so within computer science, with it being such a revolving providing update information, it's a little bit hard sometimes to find things. So we look out to outside resources to make sure that we have relevant resources to provide our clientele and provide our participants. So I want to take the next few minutes to discuss each activity. And so I hope in your guys' group that you guys have created a host, a talk person for each breakout, each activity. And so if you would unmute yourself, if you're a host, if you're able to, I'm going to next go through each activity, and when your activity comes, make sure to unmute yourself and share about your activity. So our first one is the Ozobots. If you are the spokesperson of that group, please share what you guys learned today.
Laura, we were chatting. We didn't get one designated, but did anybody want to hop up?
Yeah, I can go ahead and do it. All right, so we learned about Ozobots, little programmable robots that are suitable for ages 5 and up. However, younger ages between 5 and 7 have a more difficult time with the programming aspect of it. But since Ozobot can also be programmed by colors, you can draw little lines that the robot will follow. Not only that, it will match the color to those lines. The program can be used for many different subjects, not just computer science, but we can also relate it to arts. I've used it for math and, well, STEM-based in general. But also another suggestion that we've had is I've had the kids draw little patterns while using the codes to act out a little script. So they would have one person would stand off to the side reading a script while the robot would go.
Awesome. Thanks, Richard, for sharing.
A very versatile little robot.
Cool. Ozobots is an awesome little program that is sometimes really hidden. You don't get to see those very often. Brad, if you get a moment, if you wouldn't mind linking those links sharing those links in the chat box. You can share it all at once, and we can wait at the end, or you can do it one at a time. Either way is okay. But our next activity that's going to be shared is the virtual reality.
Hello, I think that was ours. It was Mesa Mountains in Colorado. Okay,
Yeah.
so okay. I just want to make sure I'm on the same page. And anyone from my group could gladly, I would love if you would jump in if you have something else. It was a little complicated for me at the very beginning, just some of the instructions, but so we saw a game piece, and on there, basically they had to go all the way up to the top of the mountain. And so on their way there, they had to answer computer science questions to make their way up the mountain. And so there was a few things going on. You had plants, and if you landed on a plant, that was a good thing. There was tokens you could gain. There was also obstacles involved. And you wanted to avoid that because that could set you back and make you have to start all the way over. So you had spiders, vultures, those were some of the obstacles. And they had about 20 minutes to try to make it to the top. So it was definitely a group activity. We were talking about it being more of a small group activity. And so one of the questions that they would be asked is like, what language do computers use to process data? And players couldn't occupy the same space at the same time. So, and this was something that was interesting. If you reached 3 obstacles, the expedition failed.
Awesome. I just wanted to double check because with the virtual reality, Elaine, was that yours?
Yes, Laura.
Okay, awesome. I wasn't quite sure what virtual reality session that Elaine had, and that's wonderful. If you guys have not explored virtual reality, Brad has shared the expedition in the chat box. That link is a great resource. Know that the extension office does, our Missouri 4-H office has 2 virtual reality kits that we our staff, 4-H staff, has the opportunity to check out to do programming out in the community. So if you're a school district or in a after school program that is not really familiar with virtual reality, know that those tools are accessible through your local extension office. All right, so our next virtual reality, our next activity is the 4-H STEM Challenge, also known as, or formerly known as, the 4-H National Youth Science Day kit.
Don't think too many people in my group wanted to share back, so I'm Amanda Meek, but I was the host for this session. So we went over the 3 activities and mostly saw the Hack Your Harvest, but just giving kids a taste of some computer science. The Hack Your Harvest is kind of just a non-computer activity. So the kits themselves do have 3 activities, with 2 of them being non-computer, and then Pitch Your Passion, which uses Scratch and computer science. They're great kits, and I think they could really be a benefit for a lot of the after-school sites. And I do have some kits, so if you're interested, send me an email and we'll get that figured out. It's Meek, MEEKA, @missouri.edu.
Awesome. Thank you, Amanda, and the team that explored that that computer science activity. Those kits are amazing. Like Amanda said, those kits are have lesson plans. They have them connected. Most of them have majority of the supplies you need. They're definitely a great toolbox to have. And so and definitely, if you have not seen them or heard of them, definitely check them out. Brad also linked the website in the chat box, but as well as Amanda said that she actually has some, and so a great opportunity to get those in your hands. So definitely email Amanda. I will provide her email at the end where you can screenshot all of our emails. Awesome, Amanda. I just see that she put it in the chat box as well. And so we just get a hold of Amanda. All right, so moving on to our next activity, we've got color by numbers.
Okay, so our groups kind of brainstormed together to summarize the activity. We talked about how computers display images on a screen, and we used graph paper art as kind of the basis for it. And I didn't get to share my graph paper art example, my paper form, but it's kind of like this. It's a happy tomato, and you would make a code for it with ones and zeros as well, using like graph paper or regular paper. But Computer Science Unplugged, it's one of the activities online, and they have templates that you can use as well, starting with black and white, and then moving on to add colors as well. So it's basically taking a code, and then they will use this code to create the art as well. And if any of my group wants to contribute anything, they're welcome to at this time.
Yeah, so I was in the same group with Kaylin, and I think this is a really fun project. It doesn't require a lot, and she showed us a couple of scales. And she started with something basic as the letter C. She showed different scales as to how we can make it fit the age groups that we're particularly working with, which was really good.
Very cool. Is there any others? I don't want to step on anybody's toes before we move forward, before I add. Okay, so so one great thing about the color by numbers, but also if you have not checked out the csunplug.org, that website not only has the activity that Caitlin introduced to you guys today, but is additional, like, lots and lots and lots of great things. And so I would highly suggest you checking out that website. One thing with computer science, it's really important that we offer the opportunity for the kids to unplug. We know that kids are on electronics a lot of times, a lot of moments of the day, even now that we're going a lot of virtual learning. And so these activities allow the kids to understand and get those, but also learn those terminology like debugging, algorithms. There's lots of terminology there that they may not typically know. So it provides them a background of how things work in a computer or any computer science mechanisms. And so I'm going to have Brad share it. Brad, on that very last edge, there was, or very bottom of that list, there was another link that, and I think I had it because it was a link from the video that I shared from you guys today, but that video also it came from a website that has tons of other resources as well. So I want to make sure we provide it. If we don't get that in there in the chat box, I'll make sure to get it at the end. But definitely check out those unplugged activities of computer science. Yes, this curriculum code.org is the other website that Brad put in there. All right, so moving on to the next activity, we have Scratch.
Laura, if you'll let me share my screen, I can show what our group did, okay?
Yeah, I'd love to.
And then the group can figure out who is going to talk about it here. So,
sounds great.
I'll talk about it if no one else wants to.
Perfect. Give me just a second here. And here we go. Hopefully. All right, Megan, it's yours.
All right, so basically it's a very simple animation that you can create. They have a drop down menu. You kind of just drag and drop. Yeah, okay. for different sounds, different positions, music you want to play for a certain amount of time. We couldn't figure out how to stop that same sound from repeating over and over again. But we were talking about applications such as if we had a big family night and the kids wanted to make a little animation for the beginning of a presentation or something and all work on it together, or if we were stuck in the computer lab and we brought this activity up, it'd be a very good peer learning experience. Some kid would see another kid doing something, oh, how did you do that? And teaching would happen. You can import your own images and sounds and stuff too. That gets a little more complicated for the older kids, but it's just a cute little creative tool around and see what you can do kind of program. Yeah.
That's awesome. And is there anybody else that want to share a little bit about Scratch before I jump in? Great. Thank you guys for sharing about Scratch. Scratch is actually one of the easy ways to get kids interested into computer science and into more of the coding and breaking down things. So a fun little thing, my daughter that is age 12, my oldest, she is actually participating in a statewide project right now in Scratch. We have another colleague, I'm trying to remember where Casey's at. She's like in St. Louis area or like on the east side of the state. And so my daughter's able to interact with other youth while doing Scratch, and she's really enjoyed seeing and having to create an animation. Scratch has lots and lots of resources for educators to teach Scratch. So there's a couple of different directions, and so first off, if you go to Scratch and create an account, you can enter in as an educator, and they give great lesson plans, as well as 4-H also has 4-H Discover. They're actually a Utah university, has wonderful curriculum all around Scratch, and great resources as educators to be able to know if a child is having problems, how do we, you might not know it, but yet able to teach it and be able to learn aside them and to debug or to problem solve on things. And so definitely reach out, look at those resources out there. In the lieu of talking about how Discover 4-H has some great curriculums, they also, I'm going to start sharing my screen here again.
Laura, I'm going to throw in there, I'm going to give some credit where credit's due. 10-year-old was the one that started that whole thing, and then we just altered it from what was there. So she thought that was the best thing ever, that she didn't have to sit down and do her pen and paper homework. She really enjoyed that.
Good. And that's what Scratch is, such a versatile thing. I really think even my 7-year-old would be able to sit down and do it at the very basic level. And so there are tons. It's a free platform that you can register on. It is kind of a social media, like you can share things and share your projects with others. And so just keep that in mind. Look, some school districts have probably blocked it. So just kind of keep that in mind, search it out and see if it's actually something that works well in your guys' learning environment. But it definitely gets the kids engaged in that first coding concepts, for sure. So good job, Mallory. So as I mentioned, 4-H Discover has a Utah Discover curriculum about Scratch, but they also have coding as well. And so I think this is our last and final group. Would love to hear what you guys learned.
Okay, so we pretty much were coding similar to Scratch, except for it was set up like a maze, Angry Bird maze.
Cool.
And for each drag and drop direction, that's the direction that the little icon would move until you put in the right code for it to reach the finish line. So
that's cool.
The age range, it looked to be from 5 and up as well. It wasn't too complex, but we did struggle to start with. So
Thanks for sharing,
That
Jonathan.
was pretty much it. No
Okay.
problem.
Thanks. Is there anybody else that want to share anything about what they've learned? If you wouldn't mind, utilize the chat box and share with us what were some of your aha moments. Like, do you feel more comfortable now learning and sharing computer science activities with others and with your participants in the school districts or in the after-school program? I would love to see your guys' comments as I talk through kind of wrapping up today's presentation. I hope that you guys were able to learn a little bit about what computer science activities are kind of out there and what different platforms and resources are out there, but as well as why we want to make sure that we engage youth into those learning model and ask those questions on to get that checking for understanding. Even though that we may not be able to work with our kids one-on-one or one-on-5 on a different topic area, I hope you guys really take the understanding of why it's important to have those reflection questions. And so kids are able to learn better and to put those things that we're teaching them in what I call a filing cabinet up in our brain. And so we're able to recall them, recall those ideas much faster. And so today, if you wouldn't mind to help out our team as we presented today, make sure to fill out our evaluation. Brad will be sharing this link in the chat box here soon. And this evaluation really helps us to know, did we do a good job, be able to answer the questions you guys needed to question, was it reliable, what you needed, as well as if you would like more feedback and like to be more engaged with Extension, there's definitely room for you to add your contact information in there too. So to finalize, we have a few more minutes before we close for the day. If you, I would like to just kind of open up the floor for some questions and even some discussion. So I'd love to hear what you guys is, if you guys have any questions, I'll be glad to answer them. And also if any of our 4-H team would like to jump into and answer the questions, that would be helpful too.
So yeah, I was trying to copy the link and it told me that I have an unsupported browser. We will put this.
Okay.
We'll put the PowerPoint on our website, on the MASN website, and you'll be able to access it then. If somebody else can copy it and paste it in there, whether it's one of your team, Laura, or that would be great. I clicked it and it said that I am in an unsupported browser, and I was like, people don't need that. So I don't know what the.
Let me see if I can get it in there too.
Yeah, and then, oh, there we go.
There we go.
I won.
Yeah.
Yes, so that link is valid. I was able to pull it up. So make sure to use that link. It's very important. Not just like, we really appreciate your guys' feedback. Your feedback allows us to do reflect, apply. And so we appreciate your guys' feedback on that and utilizing that evaluation for us.
Laura, if you want to put that last slide back up, just in case people didn't get those email addresses.
Yep.
Any of these ladies, please contact them if you've got questions. 4-H has fantastic curriculum. They're a great resource for your after-school program to partner with, to work with. So if you do have questions, please don't hesitate to contact them.
And if you do not see, if you're not in one of our areas, no worries. There's a couple of different directions. You can contact your local local extension office and just ask for your 4-H staff, and they'll be glad to help you. Or you can contact one of us, and we'll be glad to get you connected with a staff member in your area. I'm breezing through the chat box, making sure that there isn't any questions that I see in there. But I really hope today was helpful for you guys to be able to grab some great resources. Thank you guys so much for joining Brad and I and the 4-H and the 4-H team today. I really appreciate you guys taking time out of your day and just being with us.